In the previous videos I've done, the wind has been coming at the airplane directly as a headwind, directly as a tailwind, or directly as a crosswind that is blowing perpendicular to the airplane's path. The chances of any of these happening are very unlikely and will seldom happen. So in this video I will be showing how to counter the wind while it's coming at you from an angle that's more likely to happen and a little more difficult to work with. This time our airplane will be traveling 9,000 miles. An airplane will be traveling at 450 miles per hour. We'll say that the wind's blowing at 36 miles per hour. And it's going at 137 degrees compared to the airplane's path. So to figure out how far west this wind is going to blow us, we need to first figure out how long it will take to get from point A to point B. To do this, all we do is take 9,000 divided by 450, which ends up equaling 20 hours. And now we know that the wind's blowing at 36 miles per hour. So for each hour, we'll go 36 miles west. So we take 20 times 36, which ends up equaling 720 miles. Make this triangle based on the information that we already know. We know that this angle is 137 degrees because that's the angle that the wind is blowing compared to the plane's path of travel. We know that this is 720 miles because that's the distance that the wind will push us west. And we know that this is 9,000 miles because that's how far we want to go. To find this angle, we need to first find the length of side B. To find the length of side B, all you do is use the law of cosines. Which states that b squared equals a squared plus c squared minus 2ac times the cosine of angle B. After working out this problem, I got b to equal 9,539.2. So I plugged 9,539.2 in for side B. Now that we found side B, we can now find angle A by using the law of sines. The law of sines states that side A over sine of angle A equals side B over the sine of B equals side C over the sine of angle C. So after working out this problem, I found A to equal 2.95. So we now know that angle A equals 2.95 degrees. Since we found angle A to equal 2.95 degrees, we now know that that's the angle that we should turn into the wind, because as we turn this many degrees into the wind, ultimately the wind will push us back to point B, where we want to be.